So my name is Wai. I'm a solutions architect in the network programmability team, part of NETCONF Automation. I'm going to be talking to you about NetConf interoperability validation. So here's the agenda. I'm going to be talking to you about why you should be doing NetConf validation, and then introducing to you the NetConf Yang Automation Testing program, as well as covering the service automation criteria, which is sort of the best practices that you should be following when implementing the NetConf implementation for your device in order to enable service automation. And then I'll talk about the DrNet Examiner test tool, which is an NSO add-on package that would allow you to validate your NetConf implementation. And then I'll cover some resources for you as well. And then my colleague, Jonas, will be giving you a demo, showing you how to make use of NYAT tool in order to validate your NetConf implementation. So how to test your NetConf and Yang implementation? So is it enough just to be doing protocol level testing to make sure that it complies with the RFC? Well, this is necessary, but it's not sufficient. So is it enough to be able to respond to NetConf RPC calls? This is a must, but we can't stop there. So is your implementation ready for service automation? Well, it is best to find out by testing with NYAT, our NetConf Yang Automation program. So let's talk about service automation criteria. So there are both mandatory and optional requirements listed in the NetConf and Yang RFCs. What you choose to implement in your device would highly affect how easy it is to automate your device and how much effort one needs to spend in order to automate your device using service orchestrators. So there are the mandatory NetConf basics that include the hello messages, the data store locking support, and the subtree filters for all the NetConf GET requests. There's the Yang model correctness. You need to make sure that the syntax is correct and the constraints are properly defined according to the RFC. Then there's the Yang model compliance in terms of adherence to the guidelines for authors and reviewers of Yang documents RFC. You should be making use of standard defined data types whenever possible and defining proper ranges and constraints for your data types, making sure that those matches what your backend instrumentation code is expecting. Then there's transactionality, which is often the most difficult part of a NetConf implementation to get right. There's the all or nothing semantics of a transaction, meaning that only when the entire transaction of what is specified in an edit config request can be modified in a configuration data store should the transaction go through. If anything fails, if just one tiny little bit of the configuration that could not be modified due to whatever reason, the entire transaction should be rolled back. Then there's the all at once semantics, meaning that there should be no order dependency in your transaction. Any order, whichever way it comes into the transaction, should result in the same modification in your configuration data store. Config validity depends on config alone. The valid configuration should never have to depend on operational state. Lastly, no auto config, meaning that the configuration data store should be modified exactly as it is specified in the edit config request and nothing more. So in order to get the transactionality part of your NetConf transaction to be done correctly, you need to make sure that the transaction, the getting to a particular configuration state on your device should be made as predictable and as repeatable as possible. In order to get from a configuration state A to B, one should only have to figure out the deltas between the two configurations and nothing more, without exception. So the key to automation is to eliminate any custom error handling coding. If you can achieve that, then there's close to zero effort, right, in being able to automate your NetConf device. So more details on these automation principles, along with others, I have included a link later on my resources slide that will point you to the video series that my colleagues and myself have been working on that are called the Advanced Automation Principles. Oh, so this is an old set of slide. Okay, I will skip through these. Okay, so let's talk about our NYAT program, some commercial aspects of it. It is a free service open to equipment vendors. You get either the NSO software if you rather want to work with NSO directly, or you can get the what we call the NYAT container. It's the containerized version of our tool. And then you can make use of the NetConf net builder that comes with NSO in order to build a NetConf net for your test device. And then the DrNet Examiner tool, as I said earlier, is a NSO add-on package. And then you also get technical support via email. And what you have to bring to the table is a device or system to do the validation on, and then a machine or system in order to host the NYAT tool, which is NSO plus the DrNet Examiner package, or in the form of a Docker container. And then you would want to make use of one or more use cases, the ones that are being used by your customers, or the ones that your customers should care about, and then a handful of typical configs for each of the use case. So this program is designed for equipment vendors. However, we are also making the tools and documentation available to service providers. But we strongly suggest service providers to encourage your equipment vendors to participate in this program in order to find out any potential issues firsthand. That way they get to fix it during their development, or at least prior to delivering the products to you. So what is the minimum success criteria for this? So you don't want to target 100% coverage. There's really no reason to have to do that in order to validate your NetConf implementation to find out whether it's ready for service automation or not. What you want to do is to select one or more common use cases for your product. And then for each use case, you would define a day zero base configuration and a few day one running configurations as test cases. And then you would use our DrNet Examiner tool, which runs inside of NSO, in order to demonstrate that all possible combinations of state transitions for the defined test cases can be achieved successfully. Here's just a simple diagram that shows you sort of the workflow that it helps with iterative development process that you can start out with defining a subset of your Yang, or a subset of the functionalities in your Yang model, and then you can validate. You can start validating the use cases, even with a few of the Yang models that are ready, and then you can keep on adding to it. Then the end result is a list of validated use cases. Let's see. So the DrNet Examiner package, it is a NSO add-on package, as I said earlier, that is available for download from our NSO developer GitHub. It provides you with automated NetConf and Yang capabilities for testing devices transactional behavior. It verifies that a device will accept any valid configuration, regardless of its current configuration and operational state. It verifies that there's no auto-config, that the transaction modifies only what is specified within the edit config request. But it requires the user to specify a good selection of input configurations, meaning the configurations that are most relevant for your use cases. I will skip this part because you will get a demo from Jonas on this. And, well, unfortunately, this piece is old. So I actually was planning on sharing with you some resources on where you can go and sign up for our NYAT program. That will then give you the link for where you can download our NYAT tool. That will be the NYAT container. And the link for downloading the NYAT user guide, that one is correct. The second bullet is correct. And so is the third bullet, which is giving you an interactive demo on our NYAT tool. And then lastly, I was going to give you a link that would show you where you can go to watch our video series on the advanced automation principles. But I will talk about one slide before I pass it on to Jonas to give you the demo. So there are one of two ways in order to make use of our NYAT program. One is with the container approach. The other one is by installing NSO and DrNet Examiner directly on your OS as OS applications. So by far, it's easiest to make use of our NYAT container because it's already taking care of all of the dependency issues, right, between the package dependencies that's required in order to run NSO and DrNet Examiner on your OS. So at least you don't have to struggle with that. And then also, it's packaged in such a way that you can either work with NSOs or NCS CLI directly in order to execute the commands to perform your testing, or you can make use of the wrapper commands, which are being provided on top of NCS CLI in order to save you some typing in terms of like onboarding the device, building the NetConf net, as well as running some of the DrNet Examiner commands. So that would come in really handy. And then again, if you rather work with NSO and DrNet Examiner directly in your OS, you can also choose to do that. And you can download the NSO software directly from DevNet, which you will then follow along in the instructions in our NYAT user guide in the link as listed in the second bullet. That will show you how to go through the steps to install the tool, as well as running the test. So that's all I have. I will pass it on into Jonas, who will give you a demo on NYAT.
Thank you, Wai.
Okay, sure.
Before you leave, do anyone have any question for Wai? Just shoot.
All right, we can skip that. I need a power.
Get the power button.
What's that? Yeah. We have vendors that have already signed up. Yes.
You switched to play. Great, thanks.
Are we good there? We have the, here we go. Let's see if this works. All right. All right, so we have, we should do the recording, right? Here we go. All right, so we have two containers running here. One using the NYAT tool, like we talked about, and one using a simple device simulation. And what we will show here is that we start with onboarding the device using the helper scripts that Wai mentioned. So the first one uses just the device onboarding, taking IP address, port numbers, and things like that as arguments. The second one is to build the NED, and the most interesting arguments here are the NED name and the source of the YANG models. In this example, I will fetch the YANG models from the device using the get schema functionality in NETCONF. Another option is to fetch the YANG models from some offline source like GitHub or whatever, where many device vendors publish their YANG models. If any one of you earlier has built NetConf NEDs using the NetConf NED builder, you know that there can be quite a bit of typing involved, and this automation here is a much nicer way of doing it. All right, what I wanted to type was show running config devices device NC0. And we see that we have a new device, it's onboarded, we fetch the host keys, we have it correctly configured, and we have loaded the NetConf NED we just built. So what I like to do at this point is to save the start configuration using another component of this automation script. So that saves the current state of the device configuration as a configuration for later use with DrNet Examiner. So what we are going to show now is a few different ways of establishing these device configurations. One way is obviously to use the NSO CLI and enter the configuration as you normally would do. And what I'm going to set here is set up an NTP server. And like that, we commit the configuration. Now it goes to the device as well. We record the configuration in NSO using the built-in DrNet Examiner commands. And we call this NTP. Another way of achieving the same thing is to log into the device CLI and make configuration changes there, and then sync them back up to NSO. And what we do here is we do something else, router ID and something there. We commit this. We go back to the NSO side of things, and we record the router ID configuration. A final way I'm going to show now is that we can have pre-configured configurations, which we just import into DrNet Examiner, like this. And when we have done that, we can view the current tests we have specified. DrNet Examiner, states, list states, and we see that we currently have 6 configurations stored. Look at the interface ones here. That is a special thing that we'll actually show a little bit about later. And now we can now we have two ways of running the configurations. One is to walk through the configurations one by one, just applying them once, and the other is to apply or explore all the possible state transitions you can do between 6 configuration states like that. So that would be 6 times 5 in total, 30 possible state transitions. We will try the first one first. And this used to walk through the configurations once. So now DrNet Examiner through NSO applies these configurations to the device one after the other. And as we can see here, we have an error message from one of them. And when we get to the end, the DrNet Examiner reports that there were 1 test failed. We can look closer to what that is by using another command provided by NSO to parse the DrNet Examiner, parse error logs, and it asks for what configuration files to, or from log files to use, and it reports that it's found 1 error. And then we can look a little bit closer on that error. See 0 again, DrNet Examiner, parse log problems. Problems shows a summary, and we see that we have 1 error in the time zone state. It's on line 860 in the logs. We load that, and we want to show the message lines. And it reports that we tried to set the time zone, and that was wrong for some reason. So the device here reports a validation error when we try to make a configuration change. And notice that, as you know, NSO makes its own validation based on what information it has from the Yang model. But so in this case, there we have a device which the Yang models accepts this configuration, but for some reason the device still rejects it. So there is an inconsistency in the device implementation here. Using the other way of to explore configurations works in a similar way, although we go through all the possible state transitions that these states we have recorded can be made. There are a few extra options we can use, and I'm going to use the ignore state and tell the device to ignore the time zone states, because we know there's a bug in that. And since the complexity of the state transitions here is quadratic, it can quickly lead to a huge number of possible state transitions. So it's also possible to limit the number of state transitions we do. We can use a specified number of test cases we want to test, or we can limit this in terms of time, or limit it in terms of the number of % of the possible state transitions we want to do. So let's limit it, run only for 1 minute here. And then, so this is a different, in this case we will, as it says now, start with a state NTP and then apply the rest of the configurations in order. And then it will go grab another state and apply all the configuration using that as a start state, and so on. So we always start with NTP. We went to interface 0, interface 1, interface 0, now with the router ID, and now we start. And then we will choose another start state, use and do all the possible state transitions starting from that point. and so on. So this is a few of the things we can do with DrNet Examiner. The kind of errors you typically find here is validation errors like we had here. It's auto configuration issues. The configuration you set, device does something else when you set the configuration. You can set configuration, the device reports okay, but it doesn't set the configuration you asked for. Other ways is you can set the configuration, but you can't remove it afterwards, and so on. And so I showed 3 or 4 different ways to create configuration states. One other interesting way of doing it, in case you have old CLI configurations for a device, for example, is that we can automatically translate those to NETCONF. So even if you have had a lot of, done a lot of work on the CLI side of the device, but are just starting with NETCONF, you can, we can automatically translate those tests to NETCONF for you. And another way to create test cases is, of course, to take your usual services and deploy them, and then we can record that configuration in DrNet Examiner, and you can use that as base for your tests. So, and now it stopped here after 7 transitions. That's what we had time for in 1 minute. And yeah. Any questions on this?
Okay.
Yeah.
Yes.
All right.
Wait. Yeah.
Okay. Yeah, we have one here.
It's on. I was just wondering if you could explain a little bit about how it determines these state transitions. Like, for example, it picked up the time zone. Is it going through all the enumeration states, or okay, I can see there you could have almost an infinite number of possibilities or fewer. I'm just a little bit curious. Maybe it's too big of a question.
Are you asking how you select the configurations you want to test? Or
so you have a set of configurations you're giving it, right?
Yeah.
And then is it from one configuration state to another configuration state, it's determining whether it can do that properly. Is it also looking at potential other configurations beyond what you've exactly given it? Or is it?
Currently, we are only testing exactly as we have, as the configuration are specified. So we only do the configurations exactly as configured. We are not doing any extra exploratory testing or random testing around those states or anything like that.
Okay. How did it come up with the time zone that was invalid? That's what I thought it did.
That is just I explicitly introduced the bug in the state.
Right.
That
okay.
the time zone should be just to show how it looks when we have an error.
Okay. Thank you.
Any more questions? So we will let Wai show a final slide. We'll just switch computer again.
Yep.
So this is for the projector, right?
Yeah.
Yep. Oh, great. Okay, I'll just show you 2 slides. I'll make sure that the correct slide deck gets made available to you. Oops. Okay, so Jonas already walked you through how to do it with the live demo. So I'll just leave you with sort of the workflow, right? So you would install the NYAT tool, onboard the test device into NSO, build a NETCONF net for the test device, and then using one of the 3 ways in order to configure your test device that allows you to save the test configurations into NSO, and then run the automated test. And then lastly, if you run into any issues, then you would debug it by analyzing the log files and the NETCONF trace files. Now I will just get to the program resources slide. This is what I wanted to show you earlier, where you can go to register for our program, where you can go and download the NYAT user guide, getting an interactive NYAT demo, and then lastly, the link for our advanced automation principles video series. That's it.
Thank you. So, yeah, give them an applaud.
Thank you.